you very much and welcome this morning after the keynote session. I will talk a little bit about the concept we came up with, which we call DMZ Salt Master. Just very shortly about me, my name is Georg, or George if it's easier. Don't even try with the last name, it's German. I work for Ericsson, and I'm in my team a Salt developer basically, and I actually got to use Salt for the first time 1 year ago. And Kevin in the back helped actually a lot to train me to answer questions and also to develop many of these things later on. So I'll just briefly talk about what I'm actually doing, why we needed to do all these things with the problems we faced, and then this DMZ concept we came up with, and then a little bit more about the details we had to implement and how these dates and modules actually look like. So for the people who don't know it, Ericsson is a pretty big global company. We are in 180 plus countries. We have currently around 95,000 employees, and around 35,000 are actually working in research and development. We hold a lot of patents because we're actually pretty active in mobile networks. And this is, with the business areas networks, our biggest part. So we build everything from the core network to the base station for any mobile operators out there. Then we have this thing called digital services, where we do all the other stuff, which is basically not necessarily hardware for the operators, all the software they need, billing, running, maintenance, everything. We have also managed services, so we can actually do everything for the operator if he just pays us. So if any of you want to run a mobile network and don't want to do it yourself, we can do it also for you. And then we come to this nice thing called technologies and new businesses. And that is where I am working, and we are always looking for new ideas, create new things. And that is where actually the product which we call Industry Connect came from. And what we try to do is to create a very tiny mobile network for industry customers, meaning a room, maybe just a factory hall, and connect that with a mobile network, with a private mobile network, to keep all the data on site without the company actually needing to invest into an engineer who becomes a real mobile network engineer. So we want to make it very easy to use, very easy to install, and also very IT-centric, because in industry customer, you might find IT, but you will not find the type of IT you find in a mobile operator. Industry Connect, what we deploy into the actual customer, onto the customer side, is basically 2 servers. And then, of course, radio hardware, because you still need to transmit something. The servers we call network controllers, so if that comes up, just remember it's just 2 servers. The servers itself, of course, what we call in the base image, they run an operating system, and then we install a Salt Minion, a VPN client, and we actually install Docker on it. And of course, there's some network interface configuration. And this is done in the base image, and we did it initially with just a simple shell script during the installation of the operating system. And this shell script was kind of interactive, so it asked you a lot of different configurations for the individual customer where we would install these servers. And then even in the early stages, we had Salt actually deploy a lot of the other stuff, which we have here in green. Our core network components, we deployed all as Docker containers. And then, of course, performance management, alarm management, logging, individual configurations, and some more networking configurations. That was then done by Salt. How does that look now into a little bit of a bigger picture? Because the network controller, we want to make it very easy to use, means we have to have a front end for that, because the core network is still very complicated. So what we did, we actually connected these network controllers through the VPN back to cloud-based management. The cloud-based management then has a network management portal where all the users can actually go and do all the configurations for the individual setup. And we, of course, also have a network operating center for us where we can monitor all our deployments. For this talk, I will very much focus on the network controller itself and the cloud-based management. These basically, of course, they are comprised, first of all, of a Salt master in the cloud-based management and a Salt minion running on the network controller. For security reasons and to make it a lot easier for ourselves, because we of course have to tunnel out of a customer network, we created a VPN tunnel between the cloud-based management and our network controller. So we have a VPN server running in the cloud-based management and a VPN client on the network controller. Then we, of course, we run an API which interfaces with the Salt master to trigger a lot of the individual actions which need to be done. And for example, if a customer goes and changes something in the network management portal, that goes through the API back to the Salt master. And then we are actually running SaltStack Enterprise. We run that in our NOC so that our own support and operations personnel, they can monitor what is going on the network controllers. And on the network controller itself, the Salt minion, of course, it will monitor, configure, and run all the local programs, most of them in form of Docker containers. So a little bit about why we actually needed to come up with something new. First of all, with Salt and how we actually do all our stuff. The first thing we figured out pretty early, we of course, if we have this cloud-based management with one Salt master, we can have multiple customers connected to that. So we have multiple network controllers with several minions connected to the Salt master. No problem, standard solution. But for latency, SLA, and even legal reasons, we were actually forced to create multiple other cloud-based management instances. So very easy already for latency reasons in the US and in Europe. If a customer in the US only has the Europe-based cloud-based management instance, it's getting a lot slower, the reaction times goes down, and transferring large files for configuration or so actually gets a hassle as well. So what we did, okay, we have multiple instances. During running the script to install the image, we simply already select the cloud-based management instance we want to go to. And by that, we install on the customer side, we run the script, we select where we want to go, and everything is fine. But then management came and said, hey, we finally figured out a delivery process. Yeah. The delivery process looks like following: that a manufacturer ships the servers to a warehouse and a shipping company. There, the shipping company can then install an image we provide to the shipping company, and they will actually install it on the servers. And then the shipping company sends out random servers from the stock to the customer. And we try to argue a lot with them, we try to bargain, we try to find out what we can do, and no, they cannot tell us what service they will send. So that, of course, creates some additional problems for us, that actually, first of all, there might be even older images shipped to the customers, because they promise that they will keep up all the servers on stock, but better safe than sorry. Furthermore, we don't know which server will actually be shipped to a customer, and that means we actually don't know in the Salt master which minion is at which customer. Of course, later on you might figure it out, but in the initial installation where you actually apply all the different configurations for the individual customer already, you have no idea. And if you only install one site at a time, one customer at a time, that might work. But of course, you want to scale up. You want to be able to install multiple customers, and then it gets tricky. Furthermore, we have some security rules which we have to abide by as well. And of course, our customers are very much in favor of security as well, since we place a server, a networking component in their customer network. So the first thing we have to do is we actually have to have individual VPN connections per customer. So we cannot just create one big VPN network, but it needs to be individual, because one customer does not want to have their part connected to another customer's, maybe even a competitor of them. Then the customer networks, often very much with the firewalls, only let connections out. And often enough, these firewalls or the networking components are actually also controlled by third parties from the customer. So the customer does not even have the possibility to look at their own network or to configure their own network components. So we have to go out from the customer network and we cannot go in. And then, of course, a little bit of security for us as well. We don't want the customer to actually access our servers. So in general, we have to connect unknown servers with a possibly older image to a customer-specific cloud management instance through a dedicated VPN tunnel. And that's where we thought about this, what we call DMZ concept, which is basically very easy. We use a common DMZ VPN server and a common DMZ salt master to connect all new servers. When they're connected, we can actually update the image and security patches on the servers so that when they finally connect to the production network, they are up to speed. And from this DMZ, we are then, or we need to be, and we are able to hand over the servers / minions to the specific environment for the individual customer. How does that work? So the DMZ is basically a little bit of the same thing like the cloud-based management again. We have a salt master and a VPN server again. When a new server is now installed at a customer side, this server has, with the base image installed by the manufacturer, already a common VPN key and a specific or the common VPN salt master IP address configured. So as soon as they come online, they directly connect through the set up a VPN tunnel and connect to the salt master. From there, we are then very easily able, with reactors, for example, to install images, newer images. We are able to set up patches, everything we need to do to bring it up to a certain security level. As a next part, we actually then, when we know the individual minion IDs, we trigger through the specific cloud-based management salt master. We contact the DMZ salt master and tell him to start the migration process. Furthermore, through that call, we actually transmit also in inline pillars, basically the configuration options, including VPN profile and VPN keys, as well as the salt master IP or DNS address for the cloud-based management instance. And that, of course, then triggers salt state or several salt states, which then tears down the old VPN connection and sets up the connection to the new server. And from there, we are then able to simply, with a high state, install all the necessary stuff, all the customer-specific stuff we need. So before, we had a custom image installed by Ericsson, personal with a script, which also meant that either the servers need to come to Ericsson, which with the new delivery process management created is not possible, or Ericsson personnel needs to be on a customer side every time we install a new server, which was also not really in favor of management. Furthermore, we created actually a lot of dependencies in the image itself, because it needed to know all the possible environments we have. And if we create a new environment, we need to update the image so that we actually can select it during the installation process. After we introduced this DMZ concept, we very much can install all the specifics for the different instances remotely through Salt. And that keeps our base image, which gets installed by the warehouse and shipping company. It keeps it very, very clean and completely independent from any other component, especially since we can even do security updates through the DMZ. The only problem we still have or had, that we need to identify the servers or the Salt minions. But one thing we actually did, we let the customer do it for us. So for the Salt minion IDs, we simply used the service tags, which the manufacturer put on the servers to identify them themselves. And they are mostly available through IPMI, so we read that out. We put that as minion ID. And the manufacturer very nicely prints these labels also on the server itself. So when the customer got the servers, we just told them in the web portal, please input the service tags. And through that, we get the information which service tags, with which minion IDs are for which customers. So a little bit more about the details, how we actually had to set up this DMZ, and a little bit about the states and modules we had to write for that. The first one, of course, the DMZ Salt Master. It needs to auto-accept all the new minions. It's one option, auto-accept true, and all the new minions will be able to join. Then one thing we found out very early, where Kevin helped us a lot in the beginning, when you change a minion from one Salt Master to another, you normally have to delete the master key on the minion. Otherwise, the minion will not accept that, the new master. One thing how you can actually mitigate that very easily, and probably a lot of people who have set up Salt Master clusters are doing that already, is by using signing keys. It's just a couple of options you have to do in the Salt Master itself and in the Salt minion, and then you create master signing keys. And that means basically when the Salt Master sends its own master key to the Salt minion to identify, the minion does not check for the master key itself, but it checks whether this master key is signed with the right public key. That also means, of course, you have to have the public key on the minion, which we can very easily do with the base image. And by that, the minion is able to basically connect to any of our Salt Masters in any of the cloud-based management instance without us needing to do some magic, or even without us needing to do commands in Salt to delete this master key from the minion. And one thing, as I said before, the Salt Master from the cloud-based management instance contacts the DMZ Salt Master. We do that simply by having the Salt Master use its own Salt minion to call the Salt API on the DMZ Salt Master. One other thing, of course, when you do the handover, and if the handover doesn't fail, you suddenly have a server which is not connected to anywhere. So we built in a auto recover or failback mechanism. And we simply wanted to do that with a reboot so that the customer can, in an emergency case, just pull the plug it in again, and it will connect to the DMZ again. We had quite a long discussion, and we had a lot of ideas how to do that, especially since the master IP is in a master.conf file, for example, in masterd. What we then came up with, we actually don't have the master.conf file itself in the masterd directory, but we have a dynamic link which links to a file in another directory. And this then contains the IP of the master. And what we do during the migration, we just create a tempfs in that directory and create the new file with the new master IP address. With a reboot, this tempfs simply gets lost, not created, and the link again points to the old one. And we simply schedule during the migration a reboot with an AT command. In 5 minutes in the future, issue reboot. So if the server is not fully migrated until 5 minutes, it will reboot, it will reappear in the DMZ, and we can start anew. So from the salt states and modules, we basically use orchestration to handle all this. We trigger that migration orchestration through the API in our cloud-based management instance. And the first thing it will actually do, it will call a sync DM sorry, it will call a sync DMZ state on the DMZ salt master, and it triggers basically a sync of all the modules and states between the DMZ salt master and the new salt minion. Then we will actually trigger the real migration, which actually will call a state apply on the DMZ salt master, which then applies a state file on the minion to actually set up the new VPN connection and the new salt. Then we wait for the first authentication of the new minion in the salt master. We accept the key. We wait for the minion to actually start up so that the minion is ready to get the new, to receive any new commands. And then we apply a keep minion state directly to the salt minion, which is now connected to the new cloud-based management instance. And then we clean up a little bit after ourselves, so we delete temporary keys. For example, in the DMZ salt master, we delete the keys of the minion so that if they return at one point, because they're actually newly installed, for example, they can connect again. So just a little bit of code snippets out of that orchestration file. As you can see here, we basically, from the orchestration, we call a lot of state files. And they all have this DMZ API, DMZ user and password, which is the credentials for the salt for the DMZ salt API, which we need to call the DMZ salt master. And then in the migrate minions, you can actually see that there we have the new salt master IP and the new the VPN profile for that individual minion, for the customer-specific VPN server. So we get the salt master IP and the VPN profile. We get that basically from outside through the API, just to make it even more dynamic for us. Then we simply wait, as I said, for the minion to come up to authenticate, accept the keys, and wait for it to be ready to receive any commands. And then we have two other states. The first one with keep minion, which targets the new minion now directly, and the delete temporary keys, which goes through the DMZ salt API again. The individual state files look is where we have done a little bit of more customization now. We have written custom execution modules to map the salt API to states or executions, so that we can, in the state files, actually call them. For example, the first state we call here is salt API auth, and this is needed to actually authenticate with the salt API. And there we, of course, give the DMZ user and password, and that will save then all the authentication tokens in context. And then we use here the Salt API query, which sends a query to the Salt API to execute a command. In this case, our target function is Salt util sync modules. So we want to sync all the modules and states. We can also do the same thing, for example, with test.ping to see whether the minion is actually alive on the DMZ Salt Master. We install the VPN profile, which I have cut out here right now. But then we have a state.apply where we actually go and call a state execution on the DMZ Salt Master as well. So both simple executions as well as state files are possible. And we also, with another Salt API wheel command, we have also mapped in the custom module any key functions. So we can simply delete the key as well. The migration stateful on the DMZ Salt Master itself, it has then the magic with the tempfs. First of all, to make the the VPNs recover after reboot, we simply work with systemd. We enable the old VPN. We have the new VPN disabled. We make sure the Salt minion is enabled, so it will restart or it will start after reboot. The first thing after that is we very much issue the AT command. So, or we make sure that the AT daemon is actually running. And then we mount the new file system, the tempfs, where we write with file.managed, we simply write the new Salt master IP into it. And then we work with the Salt inbuilt schedules. So we have different schedules, which we simply send to the Salt minion, where we say, okay, first we want to, after this is done, after the state file is executed, we want, after 30 seconds, we want you to tear down the old VPN. After 45 seconds, we actually want you to set up the new VPN. And after 60 seconds, we want you to restart the Salt minion. So that even if the connection in between breaks, the Salt minion will still continue until the new connection is set up. And after that is done, we issue the failback command with the emergency reboot. Then for the keep minion, we kind of do the reverse. The first thing we actually do in Pillar, or no, not in a Pillar, in Ginger, is we actually read the Salt master configuration file, because we actually have not found another way how we can save the contents of a file in one state file. So we read it as with Ginger, and then we unmount the tempfs, and with file.managed we write the contents of the master.conf file into the now on the host file system existing master.conf. And then we stop the emergency reboot. We disable the DMZ VPN, so with the reboot it will no longer create that VPN, and then we enable the environment VPN for our normal state. And then the last thing we actually do in our orchestration is we issue a high state to install all the rest of the necessary programs. Thank you very much for listening, and are there any questions?
Yeah, just one comment on the auto-accept part. Are you aware that now you can do grain-based whitelists? So if you have access to the full list of applicable service tags, you could basically put them into a whitelist and only accept those that are in the whitelist. And of course, if you had the customer relationship, you could even then use that for mapping, but that was not the case, right?
Yeah, exactly. I mean, we thought about that, and that is where we actually talked to the warehouse and shipping company, and they basically said they cannot provide us with this information. Even though they are printed on the outside of the server, they were not able to give us which IDs, which service tags would be available. So that's why we in the end resorted to auto-accept. But since it's behind another VPN, we are sure that not many other malicious Salt minions will be able to connect. And furthermore, it's a DMZ. It is designed as a DMZ. So even if you're in the DMZ, if you manage to break in, you will not be able to infiltrate any of our other production environments. Thank you for the question.
Yeah, so after a successful migration and your minion is now connected to your production network, what happens when the minion fails? Like, how do you recover from that?
You mean the Salt minion itself?
Yeah, the server that you ship to the customer site, that minion stops responding.
We have the possibility, since we still have a VPN connection set up, we can have a recovery SSH connection to that server. This is set up in a way that we have to do some process to actually make that happen. So it's not open all the time. And so through that, we could be able to log in. We also have the possibility to actually go on site and connect to the console port to the server. Or the first thing probably support will ask the customer to simply restart the server.
So on that restart, AT kicks in, reboots, or on the restart, you're saying it all goes back to a DMZ?
I'm sorry, maybe I misunderstood your question. You mean during the migration process?
No. Like everything's successful,
Yeah.
You're humming along, everyone's happy, right? And then all of a sudden the minion dies.
Yeah, then I mean, it's like in any other case where you have a server somewhere remote and the minion suddenly dies. You try to restart it in some way. In case the complete server dies, the hard disk is fried or something, we have a recovery process where we can actually exchange a server, and basically we do a complete migration for that new server and reintegrate it simply with our on-site products. In the front row is another question.
Can you go a little bit more into details about the VPN configuration, like credential management, address management? Because we had a similar issue with.
Okay, which I have not shown simply for brevity, is that the Salt master, as soon as he gets the request to migrate a minion, it will actually issue a request to the VPN server to create a new VPN profile. And the VPN server will then put the VPN profile in a file space where our Salt master can read from. And when we then do the migrate minion, we will actually take that file where we know the minion ID, of course, and that is we use that also for the VPN profile user ID, so we know which file to take and transmit down to the Salt minion. So our VPN server simply can do user management, and most of the stuff is done by the VPN server. We just, from Salt master, then issue a request to create a new user. Address management is done by the VPN server itself. And since we anyway have customer-specific VPN servers to simply isolate the different customers from each other, they each individually get a certain address space. So we simply circumvented the issue of address there. And yeah, that of course also means we can reuse addresses between the different servers.
Any other questions?
So what about lifecycle management? If you want to do OS upgrades or upgrade the containers, is that all also going through Salt or anything specific?
Yes, that is the initial reason why we actually introduced Salt into our solution, because we wanted to have this lifecycle management capability of Salt. So as soon as the server is migrated, it is basically like a normal Salt minion server somewhere on a remote place. And there we can do upgrades, we can patching through Salt. Since we always have two servers on the side, we can do even more intrusive stuff where we completely reinstall one of the servers through the other one. This is also a possibility for support then. But most of the updates and so on, we will do through high state on a regular basis.
All right, I think that's all the questions. Thanks, Georg.
Please go into the app and rate the presentation. Appreciate your time. Thank you.
Thank you very much.